The story of the MS-21 does not begin with a blueprint. It begins with silence. With that hollow silence that hung in the Russian skies in the 90s and the 2000s, when the regular drone of TUs and Yaks was replaced by the whine of Airbuses and Boeings. It was the silence of a strategic failure. And against this backdrop, what was born was not just a new aircraft, but a daring, almost adventurous attempt to reclaim the skies. Not yesterday's skies, hazy with the kerosene of Soviet giants, but tomorrow's, digital, efficient, competitive. Ask any pilot who lived through that era. They will sigh, "We flew on whatever was available." The fleet was aging, foreign leasing companies dictated terms, and domestic designs were gathering dust in the hangars of history. The country that gave the world the first satellite in Gagarin had become a passive spectator in someone else's show in civil aviation. And it was at this point that the MS-21 was born, not as just another plane, but as an answer to the challenge of the times. A manifesto, a statement of intent. We not only remember how to do it, we know how to do it tomorrow. The goals set from the very beginning were not merely ambitious, they were precisely audacious. The task was not to copy the successful A320, but to create a product that would beat it in key parameters a decade later. The focus? On the passenger and the airline. A fuselage 7% wider than its main competitor? This is not an engineer's whim. These are meters of psychological comfort, centimeters that add up to a feeling of spaciousness, Mach confinement. A wing made of polymer composites, the largest in its class. This is not a technologist's fetish. It is a promise to the airline of a 12 to 15% reduced appetite for fuel. Every specification was not just a line in the technical requirements, but a blow to the weak points of the market favorites.
The role of the MS-21 for Russian industry is hard to overstate. This was not a project, but a total modernization of the entire sector. In fact, entire industries were built from scratch or radically rebuilt for it. Material science, those very composites, avionics, the digital cockpit, engine manufacturing. It became a locomotive pulling wagons of allied suppliers behind it, dragging them from Soviet-era manuals into the world of global cooperation and stringent standards. But the real drama began later. The story of the MS-21 is a perfect plot for an innovation thriller. Everything was progressing. Pride grew with the first flights, with certification victories. And then the world changed abruptly. Sanctions, the severing of cooperation ties. A story that was supposed to be a tale of the triumph of globalization turned overnight into an extreme quest for import substitution. Let's not mince words. For the project, this was a shock akin to a near-death experience. The revocation of the type certificate for the composite wing, the halt in supplies of key components. It seemed there was no chance. And here, the project revealed itself from a new, unexpected side. The crisis became a catalyst, laying bare both a titanic reserve of strength and the fantastic complexity of the task. The great exodus of Western partners turned not into a collapse, but into a painful, incredibly costly, and urgent organ transplant operation. On the go, in mid-flight, developing domestic composites, creating our own systems for air conditioning, hydraulics, and landing gear. This is no longer a plan, it's the reality of today. The MS-21 is rapidly transforming from a symbol of cooperation into a symbol of technological sovereignty, forced, difficult, but inexorable. Today, the MS-21 is an aircraft at a crossroads of eras. It is no longer the Russian counterpart. It is a unique hybrid of a once global idea and a hard-won national engineering will. Its fate is a litmus test not only for the aviation industry, but for the entire model of the country's high-tech development. Can it achieve the stated operational characteristics with its new, fully domestic inner workings? Will it retain the promised economic magic for airlines? Can it become not just an aircraft for domestic routes, but an export product that others will line up for?
For now, the answers are being written in the skies over Zhukovsky and on the factory floors in Irkutsk. But one thing is certain. The story of the MS-21 is no longer about silence. It's about the persistent, growing hum of new engines, in which one can hear both the excitement and the anxiety, and the stubborn hope of an entire industry. It has reclaimed its sky for battle. Now it must win that battle. And it all began with a simple yet painful thought. You cannot outsource your own sky to anyone. The late 1990s, early 2000s, the Russian sky. It was plied by veterans, the workhorse T-154s, the cigar-shaped T-134s, the compact Yak 42s. They were excellent machines in their time, but their time was passing along with the century. The world was already flying Boeing and Airbus of a new generation, quieter, more economical, with digital cockpits instead of forests of analog dials. And Russian airlines faced a cruel choice: buy expensive and difficult-to-maintain imports, or continue squeezing the last resources out of an aging fleet, risking both profitability and, far more importantly, reputation. The dependence became total. A spare part? Wait. Training? Pay. The price of a new airliner? Dictated in distant Toulouse or Seattle. This wasn't just a market. It was a financial and technological stranglehold. And the ticking clock, the average age of the aircraft, was relentlessly rising. The country risked being left without its own wings for ordinary passenger flights. The message was clear. It had to be our own. Not another modification of a Soviet classic, but a fundamentally new machine. Not a copy, but a challenge. Thus was born the idea that would later be named the MS-21, the mainline aircraft of the 21st century. Arrogant? Absolutely. But ambition is the only fuel for such projects. In 2006-2007, the idea took shape and received a budget. The task was assigned to the United Aircraft Corporation, UAC, which had been created precisely to unite disparate design bureaus and plants into a single fist. The technical specifications sounded like an incantation meant to correct all the mistakes of the past. 150 to 210 seats, competition with the Boeing 737 and Airbus A320, efficiency, comfort, and the key technological breakthrough, the extensive use of composite materials. Not just skin, but entire load-bearing wing components made of carbon fiber. No one in Russia had done this on such a scale before. It was a leap across a generation of technology, an attempt to catch up and overtake, bypassing stages that the West had spent decades on.
Yet, from the very beginning, the project carried an internal paradox, its own inherent drama. On one hand, a loud declaration of sovereignty and import substitution. On the other, sober pragmatism. To enter the global market, you need the world's best engines and systems. And so, the first MS-21 prototypes received American hearts, Pratt & Whitney PW1400G engines, and their onboard equipment became a cocktail of international suppliers. It was a calculated move to create a fast, competitive platform first, and only then, in parallel, cultivate domestic analogs. As it turned out, this duality became a projection of future upheavals. The history of the MS-21 did not begin in a vacuum. It started against the backdrop of growing state investment in high technology and the defense industry. The aircraft became a flagship not only for aviation, but for the entire policy of technological sovereignty. They invested in it not just money, but expectations. The expectations of an entire industry that wanted to prove it could do it. The expectations of airlines tired of being hostages to others' price lists. And the expectations of passengers who wanted to fly on a new, quiet, domestic plane. It was a gamble, comparable in scale to the space program. But if space is about prestige, then civil aviation is about hard economics, competition, and daily operation. From its very conception, the MS-21 had to become not just a machine, but a perfect product. Economical for the carrier, comfortable for the passenger, and politically weighty for the country. 3 in 1. With all the resulting colossal risks and complexities that would manifest in the next stage, the stage of embodying the ambitious idea in metal, composite, and a nervous system of wires and software. There was a moment when it all seemed routine. World aviation is a global Lego set. You take a wing from here, an engine from there, the brains from a third party, assemble it, and here you have a modern airliner. The MS-21 was conceived precisely that way. An elegant Russian wing, infused with American composites,
clever French avionics, reliable landing gear from one global giant, engines from another. It was a beautiful hybrid, a child of globalization. And then it began, 2014, then 2022, and the global Lego set suddenly showed its fist, taking its pieces back.
This wasn't just a refusal of supplies. It was a classic plot twist from an apocalyptic movie, life support being shut off. System by system, component by component, the project began to suffocate. The key blow hit the aircraft's most ambitious feature, the polymer composite wing. The plastic that was supposed to make the wing lighter and stronger than aluminum wasn't just a material, it was the patented magic of Hexcel and Mitsubishi. Sanctions halted the magic. Overnight, the unique wing turned into an expensive mock-up without its key ingredient. The story repeated with avionics from Rockwell Collins and Safran, with systems from Liebherr and Hamilton Sundstrand. Western partners, colleagues for decades, were now reading not technical specifications, but legal briefs on sanction regimes. Even if something was technically permissible, the fear factor kicked in. No one wanted to accidentally get hit by secondary restrictions. Joint projects were frozen, supply chains snapped with a crack. The most painful public rupture, the story of the engines. The American Pratt & Whitney, with its PW1400G engine, was the face of the project for the global market. Airlines were oriented towards it. Certification was obtained for it. The 2022 sanctions put a definitive end to that. Pratt & Whitney wound down work, recalled specialists, stopped deliveries. Russia was left only with engines on already assembled prototypes and a clear understanding that path was closed forever. The consequences were not mere difficulties, but a total rewriting of the script right in the middle of filming the movie. First, the time loop. All plans collapsed. A completed, flight-tested aircraft, just a step away from certification, suddenly became genderless. It lacked the heart and brains for serial production. The import substitution process, which had been quietly evolving in the background, was thrust onto the front lines with the order, replace everything, and yesterday. This meant an additional cycle of development, testing, and modifications. The project budget began to resemble a black hole swallowing billions for the emergency overhaul of absolutely everything.
Second, the loss of the world. The European Union Aviation Safety Agency, EASA, carefully but firmly suspended the MS-21 certification process. Without its approval, the aircraft became a prisoner of the Russian market. Foreign sales to Asia, the Middle East, and Latin America, which were so heavily counted on, turned into a distant fantasy. The aircraft, born to compete with Airbus and Boeing, was pushed off their playing field. Now it had to fight not against them, but for survival in a new reality. But it is here that the story takes a sharp turn. The sanctions, conceived as a noose, acted as a harsh, even cruel stimulant. They left no choice. The state threw resources at the aviation industry with wartime intensity. A problem with composites? An entire industrial cluster involving Roskim and VIAM was created not just to replicate, but to develop its own material and its own automated layup technology. A problem with the brains? The United Engine Corporation and CRET were given carte blanche and funding for the accelerated finalization of the domestic PD-14 engine and its PD-8 variant, as well as for creating the fully Russian Irkut-21 avionics suite. A certification problem? Its own system is being developed, based on AR-MAX standards, with the hope of future mutual recognition with friendly countries. The MS-21 project underwent a painful reboot. It is no longer an international collective project. It has become a national mission, a Manhattan Project in civil aviation. Its success or failure now meant not commercial profit, but a stress test for Russia's entire technological sovereignty.
The sanctions cut away everything superfluous, all compromises. What remained was a bare, complex, and incredibly expensive task: to build a modern aircraft in a single, isolated country against all odds. And the aircraft, slowly, with a creak, began to rise on these new, fully domestic wings.
This was the moment of truth, a reboot of the entire project. The task ceased to be merely engineering. It became existential. It was no longer just about proving that the aircraft could fly. It was about proving that it could live its own independent life. It all began, as befits a good techno-thriller, with titanic work on the ground. The hangar became a laboratory, and the airframe the test subject. The new Russian composite materials, those black wings meant to become the airliner's signature feature, were placed in hellish conditions. They were literally tortured, crushed under monstrous loads, shaken until they screeched, frozen in an icy bath, and baked in thermal chambers. Engineers searched for a weak link, a micro-crack, a hint of fatigue. Every sensor's sneeze was recorded. This was a war for trust in the material, a battle that could not be lost on paper. Because the next stage was the sky. And the sky had its own challenges waiting. The heart of the aircraft, the PD-14 engines, these are not just pieces of iron. They are the most complex orchestra of thousands of parts. They were to sing in unison with an airframe that was itself 2/3 new. The first takeoffs of the import-substituted aircraft were not a celebration, but the highest form of engineering interrogation. Test pilots posed tricky questions to the machine with sharp maneuvers. How would it react to a sudden hydraulic failure? How would it handle icing? Every flight generated gigabytes of telemetry, which later, on the ground, was picked apart bone by bone, like evidence in a case. A separate saga was the aircraft's brains, the avionics. Replacing Western processors and software was like rewriting a pilot's neural connections. The new Russian navigation systems, systems for communicating with air traffic controllers and flight controls, had to do more than just work. They had to become intuitive, reliable like a rock. But all these earthly and celestial trials were merely preparation for the main bureaucratic battle, certification. This is the very moment when volumes of reports, graphs, and protocols must come together to form the magical phrase, approved for operation.
The main cycle of flight tests for the import-substituted version with PD-14 engines and domestic systems is complete. The aircraft has shown that it can fly. Now it needs to prove to regulators that it will do so always, safely, predictably, day after day, in any weather and in the hands of any airline pilot. It's as if after a brilliant final exam, you were put under a microscope for a 5-year internship. In Russia, the main regulatory authorities are MAC, the Interstate Aviation Committee, and Rosaviatsia. They award the main prize, the type certificate. Without it, an airplane is an expensive toy. With it, it is an aircraft. The process unfolds, page by page, test by test, closing a giant list of requirements. The most nerve-wracking point is confirming safety not only in flight, but also on the ground. How quickly and safely can it be serviced, repaired, inspected? There are no small details here, from the durability of a bolt to the algorithms of the onboard computer. But a Russian certificate is a ticket for domestic flights. The global market demands its own. Therefore, in parallel, like spies on an invisible front, teams are working to lay the groundwork for certification in key countries. The sights are set on India and China, not because they are friendly, but because they are markets of monstrous scale where their own aviation industry either does not yet dominate or is open to cooperation. Every line of EASA Europe or FAA US regulations is studied. Every possible loophole for recognizing Russian certificates is calculated. This is diplomacy at the level of engineering protocols. While some are proving safety, others must learn to build planes not in single units, but in a stream. The Irkutsk aviation plant is the epicenter of this transformation. It's not just workshops, it's a testing ground for the future of the Russian aviation industry. The task? To turn the unique, almost handcrafted production of prototypes into a streamlined digital assembly line.
Does it sound boring? This is the harsh magic. It's not just about assembling a dozen machines from what's available. It's about building a system where hundreds of thousands of parts from different suppliers arrive precisely on time, of the required quality, and with 100% localization. Every bracket, every microchip is now a matter of national security. Sanctions have crossed out the old supply chains, forcing the creation of new ones from scratch. But herein lies the main trump card, if it can be played: complete independence from external pressure. When the entire stock is your own, no one can press the disabled button. The price of this independence is time, money, and the Herculean effort of organizing new production facilities across the entire country. The ambitions are bold, as they should be, within 2 to 3 years to reach serial production of several dozen aircraft per year. But between plans and the Moscow-Sochi flight with passengers on board lies an abyss, filled only by airline orders. The first orders are in. Aeroflot is the key strategic partner and, in essence, the pilot operator. The company plans to receive a total of 200 MS-21 aircraft, 108 of them by 2030, and the remaining 92 by 2032. Everyone is watching Aeroflot, from Rosia to Ural Airlines. They are not just buyers, they are co-testers. Their pilots, flight attendants, and, critically, maintenance engineers are already getting to know the aircraft. A network of service centers is being created. Manuals are being written, and specialists are being trained. An aircraft that cannot be serviced quickly and cheaply at its home airport is doomed to gather dust on the tarmac.
Now the MS-21 stands on the threshold of its most important transformation. It must evolve from a project into a product, from an engineer's dream into a workhorse for airlines, a seat for a passenger, a line in a flight schedule. This is the moment of truth. It's possible to create a brilliant aircraft, but fail at the stage of mass production and support. Aviation history knows such examples. Or, by gritting one's teeth, one can traverse this granite path of bureaucracy, logistics, and service, so that one day a passenger, buying a ticket, doesn't even think about what they're flying on: a Boeing, an Airbus, or an MS-21. They simply board and fly. It is for this moment that all these years of titanic work have been undertaken. The finale is near, but the most difficult credits are just beginning to roll.